Right, so these questions we're going to be looking at linear scale factor and volume scale factor. Now, what we've got here are two similar looking shapes, okay? And this time it's cookie jars. They're giving you the height of both, they're giving you the volume, so the volume of this one is 750, obviously it's volume, so it's centimetre cubed, and we're working out what the volume for this one is. Okay, now to do that, we just need to know how to find the linear scale, and then once you've got the linear scale, we actually cube it and then times it by the volume of the one we have. Okay, now to get the linear scale factor, we'll just call it LSF. We actually, all the linear scale factor is what this figure has been times by to get to this. Okay, and to work that one out, we just say it's 24 divided by 15. Okay, and that gives you 1.6. So what you'll find is if you times 15 by 1.6, you get 24. So that's a linear scale factor. Now we actually use this figure to work out the volume scale factor. And all the volume scale factor is 1.6 is the linear scale factor, but it's actually cubed. Now we can actually work out the size of the big cookie jar. Okay, so to work that one out, we say volume, and that equals the volume scale factor, and that's going to be times the volume of the small one, which is 750 centimetre cubed. Okay, so that is going to be 1.6, and we're going to cube that times 750. So just get your calculator, we put that in scientific, and we'll just say that's 1.6, and that's cubed, and then we're going to go times 750, and that is your volume. So the volume of that was 3072, and remember the units, so that's centimetre cubed. Okay, so these things are pretty easy. So you work out the linear scale factor, and if it's a volume you're looking for, you're going to cube it. If imagine it was an area you're looking for, we square it. Okay, so that's answer to the first one. If we then have a wee look at the second one, again what we've got is two bottles, milk bottles. We've got the sizes of both, so we can work out the linear scale factor, and we've got the volume of the small one, but we don't have a clue how many litres this one is. So first thing we do, we work out the linear scale factor. So to do that, again you go linear scale factor. That is the big size, 36, over the small size. Now, big size over the small size is always going to give you a number bigger than 1, because obviously the scale factor has to be bigger than 1 in order for it to be larger. If you're working the other way, it will be the small size divided by the large size, and the linear scale factor will be less than 1. Okay, now 36 divided by 15 turns out to be 2.4. Now the volume scale factor is just the linear scale factor, but we're cubing it since it's a volume. Now what we can then do is we can work out the volume of the big milk container just by saying volume, that equals 0.3 times 2.4, and that's going to be cubed. So we again put that in the calculator, 2.4 cubed, and that's times 0.3, and that's your answer there. So it's going to be 4.1472 centimeters cubed. Now you get your marks for working at the linear scale factor. One other mark for working out what the volume scale factor is, and then your third marks for actually working out the volume, and that's no different to the very last question. So we know the two sizes of the two sides, we don't have a clue how many milliliters that holds, but we can work out the linear scale factor just by dividing the large cup by the smaller cup. Okay, that will just keep it as a fraction. Okay, and the volume scale factor will be that fraction, but just cubed. I'll just double check actually. So if I went 21 divided by 14, that's 1.5. So that's the same as 1.5 cubed. And then what we're after is the actual volume. That equals 1.5 cubed times 160. And that gives you 540 milliliters. And that's 3 examples, okay, of this type of standard you'd get.